Problem number 11. The smallest number of obtuse angles you could have in a triangle. Well, you don't have to have any obtuse angles in a triangle. You could just have all acutes. So you don't have to have any. What's the most you could have? Well, an obtuse angle is an angle that's between 90 and 180. If you have even just one of those, you're already using up so much measurement in your triangle that the other two angles would have to be acute. Like if one of the angles was 100 degrees, that only leaves you 80 between the other two, so you couldn't fit in another obtuse angle. It's the same thing with right angles. You don't have to have any right angles, but if you have one, the most you could possibly have is 1, because again, that uses up 90 degrees. The other two would have to add up to 90. Of course, that leaves acute angles, meaning angles between 0 and 90. You'd have to have at least 2 of those. There's no way you can have more than one right or one obtuse. You can't even have a right angle and an obtuse angle in the same triangle. So you have to have at least 2 acutes. You could have all 3 angles being acute. Number 12. Will the shortest side of a triangle always be opposite an acute angle? Well, we know the shortest side goes across from the smallest angle. There's always an acute angle in there, so that's got to be true. Will the longest side always be opposite an obtuse angle? Well, obviously that's false, because you can have triangles that don't even have obtuse angles. Certainly, if you have an obtuse triangle, then yes, the longest side will be opposite that obtuse angle. But of course, you can have these other triangles where the largest side is not opposite an obtuse angle. Problem number 13. We've got some unknowns in this picture that we want to find. Let's start with the angles. I'm looking at these angles here. They make what's called a straight angle, which means they have to add up to 180 degrees. That tells me that this alpha here must be 140, because 140 plus 40 is 180. Well, now that I know that, I can easily find this angle beta. I have this triangle over here that has a 22 and it has a 140. If I add those two together, I get 162. Well, 180 minus 162 must be the value for that little angle beta, and that comes out to be 18 degrees. Okay, what about these sides? Let's focus in on side X. Side X is part of this very large triangle, and the great thing about this triangle is I know one of the side lengths. I know the hypotenuse of this right triangle is 150. Since it is a right triangle, I can set up a simple trig relationship using the 22 degrees, the x, and the 150. It would be a sine relationship. Sine 22 is equal to opposite x over hypotenuse 150. Just multiply both sides by 150 and we're all set. I'll go to the calculator and type in 150 times sine 22. So 150 times sine 22 comes out to be 56.2. X then is around 56.2 units. The last thing I want to find is y. Y is part of this green triangle. This is another right triangle. I know the 40 degrees. I just figured out the x, so I should be able to set up another trig expression. It looks like I'd want to use tangent this time, since I'm interested in the opposite side and the adjacent side. So I would say tangent of 40 degrees is opposite x, that's the 56.2, divided by adjacent y. If I can solve this for y, I'll have what I want. I'll multiply both sides by y to clear the fractions, and then divide both sides by tangent 40, and I have y. Just type that into the calculator. Of course, I want to use the full number there, so I'll go up and grab it, the 56.2 number, divided by tan 40, and that gives me about 67.0 when I round that off to one decimal place, 67.0 for side y. And we have found all the missing pieces. Problem number 14. I want to solve for b. I could work out all those pieces on the right side, but I don't really have to. I mean, I can get the b by itself by just square rooting both sides. And since I'm interested in an approximate answer, all I have to do then is go to the calculator and type in that long square root. So I get square root of 8 squared plus 11 squared minus 67, which comes out to be about 10.9. And that's it. Finally, number 15, I want to solve this equation for beta. I do know that beta is in between 0 and 180 degrees. Looks like we'll be working in degrees in this problem. I've got some simple steps to take first. Subtract the 411 from both sides. That gives me 72 equals negative 81 cosine beta. And then I'll divide both sides by that negative 81. And so I have cosine beta equals negative 72 over 81. That does reduce. 9 goes into 72 8 times and into 81 9 times. But honestly, it didn't matter. The calculator wouldn't care whether or not I had reduced that answer. Can I use the inverse cosine button to find beta? The answer is yes, because I know that beta is within that perfect zone for the inverse cosine function. That's exactly what the inverse cosine function knows about, is angles between 0 and 180. So if you want beta, just do inverse cosine of negative 8 ninths. Inverse cosine, negative 8 ninths, comes out 152.7 degrees. Of course, since that ratio was negative, I'm not surprised that I've ended up here with a second quadrant angle.